Hello student, welcome back to lecture series on statistics. I already uploaded plenty of the videos guys based on the regression. So in my today's video guys, I'm gonna explain to you all one of the important question based on the statistic. Okay, based on the regression point from statistic. Okay, so regression I already explained. There we have 3 to 4 results. They are very important guys. If you want, you can refer these results from there. So without further ado, let's get dive into our today's lecture. I'm gonna explain to you all the example and it's a detailed solution. Okay, now see that the example I took it here, which is from the which is repeated in our previous year question paper. Okay, one of it from June 22 and another from 2018. Okay, for 5 marks it repeated from the SPPU question paper. Okay, so let me read the question. Okay, if the two lines of a regression are, so we have given two lines of regression, which is a 9x plus y minus lambda 0 and 4x plus y, which is equal to mu. Okay, one is a lambda and another one is a mu guys. This one is a mu. Okay, this one is a mu. Okay, and the means of x and y. Okay, that means we have given mean for x and mean for y, which is a 2 and minus 3. Okay, that means x bar is a 2, y bar is a minus 3. So what we want, we have to find out the value for lambda and mu. Okay, we have to find out the value for lambda and mu and correlation coefficient between x and y. Okay, that means r of x, y we have to find out. So see that we have 3 target. First we have to find out the value for lambda mu, then next r of x, y, it is a correlation coefficient between x and y. Okay, so let's get dive to our today's solution. I'm gonna explain to you all detailed solution guys. It is way easier and such examples definitely coming in your SPPU question paper. Okay, so get prepared with these such examples. Okay, let me start the solution for this example. So this is our given data. Okay, we have given mean for x, which is a x bar is a 2, and a mean for y is a y bar. Okay, which is a minus 3. Okay, that means it is a arithmetic mean given. Okay, this one is minus 3. Okay, this is the given data. Plus again we have line of regression. Which are the lines? Line of regression. First line is a 9x plus y minus lambda is 0, this one, and the second line of regression 4x plus y, which is equal to mu. Okay, so we have given these two lines. Okay, so using these two lines we have to define first of all the value for lambda and mu. Okay, now see that this is the very easy part guys. Don't have anything difficult, just need to understand. Okay, the what does the x and y here, what x and y do here. Okay, now see that if we replace the value for x and if we replace the value for y in this equation, it satisfies this equation. Okay, what it do, it's x, what x does, whenever we replace x in this equation, it satisfies equation, and when we replace the equation of value of y, it satisfies this equation. Okay, that means x and y, these are the actually solution for this equation. X and y is the solution for this equation. Similarly, x and y is the solution for this equation. Okay, but in statistic, x and y and x bar and y bar both behave same. Okay, their behavior is same in statistic. So we can replace x bar y bar instead of x y also. Okay, so we can replace x bar y bar instead of x and y. Why we are replacing? The point of intersection of a two regression line xy. Okay, the point of intersection of a two regression line is a xy. That means it behaves similar like x bar and y bar. So see guys, here what I have done, as we have point of intersection of a two regression line is x and y. Okay, that means x bar and y bar also lies on the same curve. Okay, or the same line. So that means xy and x bar y bar both behave same, as they are the solution for the same equation. If they are the solution for the same equation, that means x bar y bar can satisfy these two equations. Okay, so that's why I'm going to replace x as x bar and y as y bar. I hope you all have understood why I'm replacing these x and y values. Okay, yes, so 9x bar plus y bar, which is equal to lambda, and next I replace 4x bar plus y bar, which is equal to mu. Okay, so these are the two value over here. These are the two value over here. Yes, just need to replace the value in this x and y as x bar y bar. Okay, now see that as we have given x bar is a 2, y bar is a minus 3. So if we put x bar to y bar minus 3, x bar to y bar minus 3, you will get the lambda and mu. Okay, so this one is our first task here, to find out the value for lambda and mu. Okay, next we have to figure it out, correlation coefficient between x and y. Okay, that means r of xy. Let me find out the first value, x bar and y bar over here. So see guys, here I replace the value for x bar is a 2 and y bar is a minus 3. Okay, see that 9 into 2 plus y bar is a minus 3. Okay, y bar is a minus 3 in our equation, and lambda as it is. Similarly, in second equation also I replace 4 times x bar is a 2 plus y bar is a minus 3. Okay, which is equal to mu. So I received these two equation. Go for 9 into 2, 18 minus 3, which is a lambda as a 15. 4 to the 8 minus 3 mu as a 5. Okay, so I got the lambda and mu. Okay, so here we achieve here our first target, that to find out the value for lambda and mu. Okay, so our first target, it was here to finding finding the value for lambda and mu. Okay, so we achieve our first target here. Okay, now next our task to figure it out, correlation coefficient between x and y. Okay, next task is here, correlation coefficient between x and y. Okay, so guys, for this I'm going to use r square is equal to b of yx into b of xy. Okay, r square of xy is equal to b of yx into b of xy. That result I'm going to use here for further calculation. Okay, yes, now see that using our regression line, we have to find out the b of yx and b of xy. Okay, so take the value for x and y from the b of yx and b of xy, so easily we can find out the value for both of the variables. Okay, so see guys, here using our first regression line, what we have given our first regression line, 9x plus y, which is equal to 15. Okay, this one is our first regression line. Using this regression line, I found the value for x. Okay, x which is equal to, take 9 to the other side, y to the other side. Okay, so 15 by 9 minus y by 9. Okay, this one is the value for x. So what we want the b of x over y. Now see that b of x over y, that means b of x over y, that means we have minus 1 by 9, it is over y. Okay, so we got the b of xy is a minus 1 by 9. That means here what we have, minus 1 by 9 into y, that means b of x over minus 1 by 9 over y. Okay, that means b of xy is minus 1 by 9. So if you are going to get the fractional answer, we will get the b of xy is minus 0.11. Okay, so using similarly like second regression line, we go for the b of yx. So see guys, here using second regression line, what we have, second regression line, 4x plus y, which is equal to 15. So we want the b of y over x, that means take it y one side, x to the another side. So y which is equal to 15 minus 4x. So see that we want the b of y over x, that means the value we have here minus 4. So b of y over x is a minus 4 here. Okay, I hope you all have understood how I have taken b of y over x. Okay, which is a minus 4. So that guys, we know that one standard result, coefficient of correlation between x and y can be written as coefficient of correlation r square of xy can be written as b of yx into b of xy. Okay, so b of yx we found minus 4 over here, b of xy we found minus 0.11. okay, so minus it become positive, 4 multiplied by 0.11, 0.44. okay, so our coefficient of correlation r square of xy, I got it 0.44. okay, so we want the coefficient of correlation between only x and y, so take the square root from both sides, you will get the r of xy as 0.663. okay, so this one is our required answer guys. Okay, that we want in our question. Okay, see that in our question what we ask here in question, find out the value for lambda and mu, and then correlation coefficient between x and y. Okay, so see that I found this one is the entire solution. Okay, so if you want, you can refer my entire solution. Okay, question and thereafter solution. Okay, for your preparation. Okay, see that these are the value for lambda mu. Okay, this one is the standard result we applied here. Okay, so b of xy and b of yx, and last we have these two steps. Okay, note it down guys, these are helpful for your further preparation. Okay, yes, so this one is regression coefficient between x, y and y is a 0.663. okay, yes, I hope you all have understood guys everything here in my today's lecture. So we don't have anything difficult here, just these are the existing results that I explained in my previous lecture. So if you are interested to see similar videos, guys, go and check in my I button over here, or in my description box you will get the entire playlist. Okay, that one is your support much meaningful for me. Okay, yes. So I hope you all have understood here everything in my today's lecture. Even after, if you found anything difficult, guys, let me know in my comment section. I'll come up with a similar video. So thank you everyone. Thank you for my today's lecture.